Okay, we're back again. So last time what we got working was hiding windows. Oop, disappeared, and it's back. That was pretty good achievement. The biggest problem with it is that it's fucking slow. Extremely slow. So we need to make it faster. I did some profiling. Right, that all disappeared. I accidentally crashed my machine. All the profiling stuff is gone. But I did some profiling, and the slow parts are... okay. Here. This is... it says scale, but it's not actually doing scaling. It's re-encoding. So it's taking it from, I think... BRG0 maybe into YUV 444, which is very expensive. This takes currently about 50 milliseconds every frame. And then the other thing that takes a while is this, which takes about, well, it depends on how big the window is, because that changes how much work you have to do, but it takes about 20 milliseconds a frame. So that's about 70 milliseconds a frame just on those two operations. Now, if you do your math carefully, 10 frames is then 700 milliseconds. This is not looking good. We're most of the way through 1 second and we've only squeezed in 10 frames. Plus, this isn't the only thing that we're doing every frame. We're doing a bunch of other stuff as well. So we really limit our throughput, or our speed, I guess, our bit rate, as it were, by having these parts be so slow. So we're going to try to fix them. The first thing we're going to try to do is... oh, I'm actually in the wrong part. It's this part that takes a while. Yeah, in here. Specifically this stuff. So one thing we're going to try to do is we're going to try to speed up this get image, and we're going to do that by using the shared memory extension. I know FFmpeg uses this, so we're going to use that as a crib. The big question is, where is it? Is it a device? Maybe. Yeah, XCB grab. Right. And what we're looking for is this stuff. Allocate shared memory buffer. Okay, this looks right. All right, so I did some of this the last time I looked at this, but again, I crashed my whole machine and that erased... yeah, here we go. We'll share memory segment, ID, and address. Whoops. We'll just... whoops, what have I done? What have I done? Okay, we'll get rid of that. Yeah, okay, so we need the shared memory segment. Okay, so we got a segment here. We need the shared memory ID. Okay, we got the ID. And the address. I guess that's from here. Oh, okay, so they wrap it, they wrap the address inside one of their own buffers. Yeah, I remember that. Okay, cool. So we've got to recreate all this. And probably somewhere in here. Ooh, this is a good song. Ah, no, here. This is probably a good place to do it. Well, put those in there. We'll also need in grow WinSCAP. Okay, so in here, we'll need this to be new segs, new IDs, new addresses. But do we put it here before the tags? All right, so we'll put it before the tags. So we'll go if yeah, so we just need to go, well, let's grab them. I vaguely remember the pix maps being useless. Right, there was something about pix maps maybe not working with shared memory segments. We'll cross that bridge when we get to it. But I think I remember that from the last time I looked at this. Yeah. Damn, whatever. Times by new cap. I'm getting myself confused. Okay, so we're gonna go find this, get rid of that. We'll take this, we'll go back here, we'll put that there, and we'll go if this equals realloc x context dot new cap times size of, something like that. Something like that. Okay, and so this is shared memory segs. And then this will need to come down here. This is shared memory IDs. Yep. And this is shared memory addresses. Yep. Like that. This is a good song. Okay, and then down here, we'll sneak that in there. We'll go x context segs equals new segs, x context IDs equals new IDs, x context addresses equals new addresses. Okay. All right, so that's the grow Windows capacity. Back X Windows, where we were. Right, we want to change this. This is just going to be a success fail, maybe. And you're going to have to give us the window. I think we're going to do it this way. And then we want the int pointer ID, SID, and the void pointer address. Is that all we need to set here? And then what we're going to do is we'll have an XCB pixmap t local pixmap ID. And then each of these will have like a local segment. And this will be like a local segment ID and a local address. Okay, so this does all this. Yeah, well, again, we'll come to that when we get there, but I'm pretty sure this is mutually exclusive. You can't do both this and this will be 0, this will be 1. You can't do both the backing composite window pixmap and also shared memory segment, but well, we'll see. Okay, so we're just going to copy what... yes, we'll need to bring in the shared memory stuff. So we'll shared memory get. Yep, IPC private sounds good. Right, the size. So here's the problem. We do this in here. Okay, that's not so bad. I was going to say the problem is we're going to have to redo this every time. Because every time the size changes, we have to remap everything. Because the size of our shared memory region needs to change if the size of the window changes. But I think that's not so bad. What do we need to do to free all this stuff? Just SHM DT, that doesn't seem right. Is that really it? No. What's the other thing? SHM CTL. I don't have to undo that? Do I even need the ID? It seems like I maybe don't. I only need it for this. So this will be under user x11 include xcb. Is it under shared memory? It is. Detach. Okay, I really just need the segment. All right, well, let's do that. Okay, so we detach the segment. Is that it? Where else do we do this? Oh, this is in the thing, that's fine. What is this? Oh, this is in destroy window. This one. Okay, but we need to do the detach first. Do I need to get a reply from that? I got a void cookie. I think I'm just going to ignore it. I don't think there's anything I can do. Oh, the reason I hesitate is because the server might carry around the invalid reference we're about to overwrite. I don't know if there's anything I can do about that. It says it can never fail unless the segment number is correct, so